Hi, everybody, and welcome back. So, last time we talked about all things related to atomic vectors. So, as a review, a vector is an ordered collection of elements in R. An atomic vector has the added restriction that the ordered collection of elements all have the same, like all of the elements in that ordered collection have the same class or the same type of information in R. So non-atomic vectors are, atomic vectors, but not atomic vectors, atomic vectors, but not atomic. So that's why they're non-atomic. Basically, they're just everything else, all of the other vectors. So they're just ordered collections of elements. They don't have the restriction that all of the elements have to have the same class. So atomic vectors all have to have the same class. That's what makes them atomic. Non-atomic just don't have that restriction. So we've already seen some very common examples of non-atomic vectors, and that would be lists and also tibbles. So within the idea of non-atomic vectors, we had talked about basic subsetting rules. So we had positive positional subsetting where you say, give me this entry, give me the sixth element of this vector, or negative positional subsetting where we say, give me everything but the third element of this vector. We talked about named subsetting where we say, okay, give me the element of the vector that is named subject ID or something like that. We talked about how, and this is a consideration that is specific to atomic vectors because atomic all have to have the same class, but the idea of the type coercion, and they follow the order of complexity from logical to integer to numeric to complex. Again, this does not apply to non-atomic vectors because non-atomic vectors, we can have all types of information mixed in together. It doesn't matter. And then we talked a little bit about factors and how factors are sort of like halfway between the logical information and integers. They are technically integers, but they don't span the whole space of integers from negative infinity all the way to positive infinity. There's usually just a small number of categories. And those factors are then saved as the categories represented by these labels. The labels have character information, but the factors themselves are integers. So it takes up a lot less space on the computer. They're easier to manipulate and easier to handle because they're less complex. They're all the way down back here as integers, even though the information that they represent is character information. And then we talked about missing values. And since there's these four different types of atomic information that we care about, and so the logical, the integer, the numeric, the complex, then there's going to be four different types of missing information, depending on what type of information there is. But we also said that most of the time we just type regular NA, capital N, capital A, which is technically the logical missing indicator. And R just sort of figures out what it's supposed to be. We usually don't have to deal with the others. We just type capital N, capital A, and R understands that we're dealing with missing data now. Okay, so that's our review from overall the last lesson, all of lesson 6. Now we want to get into, in lesson 7, we want to get into lists, which are unstructured non-atomic vectors. And then we want to get into tibbles, which are structured non-atomic vectors. And let me go back. Let me say lists are non-rectangular non-atomic vectors. They could very well have structure. In fact, there's a lot of different kinds of lists, particularly whenever you're dealing with statistical genetics and genomics, that have a lot of structure to them. But we're going to say that lists are non-rectangular non-atomic vectors, but tibbles are rectangular non-atomic vectors. They have a set of rows and they have a set of columns. And so you have this like grid of information, kind of like an Excel spreadsheet, if you will. We're going to talk about positional subsetting and how the same rules that we applied to atomic vectors, say give me the third thing, they work somewhat similarly to non-atomic information, and also relational subsetting. So before we had talked about Boolean subsetting or logical subsetting, and we said, okay, well, if I have this atomic vector with 6 elements in it, and I want to subset the third element, I could say false, false, true, false, false, false. And I could create a logical vector of length 6 and sort of like smash it on top of our vector and retain only the pieces of our atomic vector where I had said that the logical vector was true. Relational subsetting is actually a little similar to this idea. Relational subsetting is going to build on top of the idea of Boolean subsetting or logical subsetting. So if you need a review of that, go back here to lesson 6, atomic vectors, and then look at the Boolean subsetting subsection. And this is all about how the logic works to subset a vector. We're going to build on this idea right here a lot when it comes to relational subsetting of tibbles. So back to lesson 7. And then finally, we talked about name subsetting for atomic vectors. There's also name subsetting for atomic vectors. So let's dive in. Remembering that everything in R is an object, we have objects and then we have vectors. So vectors were the ordered collection of elements. And the last lesson 6 was all about atomic vectors, where all of the elements of the vector shared the same type or class. And then lists are non-atomic, i.e., all of the elements don't have to share the same type or class. They could be all the same except for one. They honestly could be all the same, but they're not required to, or they could all be totally different and any number of combinations in between. So again, remember that R is a vectorized language, so vectors are very, very important. Vectors being an ordered collection of elements in R. And so if we spent a lot of time talking about atomic vectors in lesson 6, or the last lesson, we're going to spend a lot of time in this lesson talking about non-atomic vectors. So let's move on and let's talk about the dimensions of an object. Now we saw dimensions in one of our previous videos, and we said that a matrix is an atomic vector with a dimension attribute. And when I mentioned earlier up above about the difference between lists and tibbles, and I said that lists are non-rectangular, but tibbles are rectangular, and then I mentioned rows and columns, what I'm really describing in terms of the R language are the dimensions. That the rows are the first dimension and the columns are the second dimension. So here's a kind of quick breakdown of what we're talking about. So if I have a one-dimensional atomic piece of information, so this an example would be like a logical vector of just trues and falses, true, false, false, true, true, false, false, true, false, whatever. It's just an ordered set of information in just kind of this one dimension. Now, if I had built out that information into rows and columns and I gave it dimension, but it still was atomic or logical, then that would be a matrix. On the other side of things, if I don't have atomic information, if I have a non-atomic information, but it's still this nice ordered collection, if you will, where like right here I have the value true, then right here I have my last name, and then right here I have how long have I lived in Florida, and then right here I have a telephone number, and then right here I have a sample of my genetic information, and then right here I have a matrix of my blood panel results or whatever. So these are all different classes of information, but there's still just kind of one thing in each spot, if you will. Now, like that would be this idea of one dimensional, because I've just got like this strand of information. The individual components of the information could be all different shapes and sizes. Like I could have a matrix in one, I could have a data frame in one, I could have an entire ggplot in one, but it's just sort of like one thing at a time. That would be a list. But if I assign a rectangular grid to this data, now we're talking about data frames or tibbles. And I mentioned that in this class, we would basically be just talking about tibbles. Data frames are like an older version of tibbles, where in this case, we would have a collection of measurements on one person. So on this person, we're going to measure height, weight, age, blood type, eye color, something else. Measure their PSA or whatever. So I'm going to do like some prostate cancer studies or whatever. And then I'm going to take all of those exact same measurements, but on a different person, and then on a different person, and then on a different person, and then on a different person. You can see there that there is a rectangular structure. because there's samples that go down the rows, and every single one of these samples all have the same measurements on them. So there's the same number of columns, the same number of features for each sample, and then each feature has this basically the same number of samples in it. So it's rectangular. There's some rows and there are some columns. So this would be a two-dimensional non-atomic data structure. So I think we're going to pause right here and we're going to get into one-dimensional lists, and then we'll pick this back up next time. See you soon.